Alright, so the plan for today is to continue with our HashMap implementation, and let's actually move it to the ds.h library itself, right? So yeah. Okay, so we have these data structures and this function implementation. Let's check ds.h for some stuff. Yeah, and the old hash table, I'm gonna replace that with HashMap because I mean, it's kind of similar, but I like the new implementation more. That's why I wanted to do it. Let me just find it. I mean, we still have to add the allocator for it to be like cool and all. So let's do that first. You'll see what I meant by using this allocator. Okay, so usually all my data structures will have this allocator, which can be a custom one. And that's in case, I don't know, you want to use this library on embedded and you don't have libc, for example, and you want to use the memory allocator. That's, I mean, it's also part of this library. So let's see where it was. I think it's I don't know if it's the first one. Oh yeah, it's the first one. So this is the allocator. You have init, you have a method for alloc, a method for free. That's pretty much all you need, right? So that's kind of how it works. It's basically a replacement for malloc and for free. So yeah, and I implemented it a while back. So, and it's also like it has its own video. So if you want to check that out, I'll try to find them just to show it. But yeah, and all my data structures will also have a separate init function with extra allocator. So let's add that. So we'll do, usually I put it first, right? So I'll call it allocator. And then as an extra argument, I say here ds allocator or something. Ds allocator. I mean, it can even be just like this allocator, but it has to be a pointer. So I do it like that. Right. And then instead of this init that I do here, I do it a bit different. So let's check out the one with the allocator. Okay, so let's imagine that in fact this one is the allocator one, right? That's the change I would do here. Oops. Like this. And instead of this null, I'm gonna use, well, I guess usually I just set this thing first, so I have it. So map allocator, and then here map allocator. Right, so the new malloc will use the allocator that we provide here. And then it's going to be interesting for the free section. Well, I think, so you need allocator, right? Init, I think we need to use this init actually here. So we also pass the map allocator, just like that. And I think that what's gonna be interesting to see is, I'm pretty sure free it works with the allocator itself, so that's fine. So if you say free in here like this, is gonna use the allocator for freeing the buckets, which is what I need. And I think we also need to free this stuff, so let's also do that. I think I forgot to do this one here. So let's, after we free the each dynamic array, we need to free, so if the map buckets is not null, we have to ds free map allocator map buckets, right? So that's how I want to free the buckets, by using the allocator. And this is just a macro, and when you don't use the allocator, it's just free. And if you use the allocator, it uses that function that I mentioned earlier, and malloc is the same, so that's quite useful. So I guess now the, let's call it, issue is that we don't have this implemented. So if we try to compile this thing now, it's not gonna work because we don't have a HashMap in it. So let's re-implement HashMap in it. And how do you think it's gonna work? Well, it's just gonna be a call to HashMap init allocator with map, with capacity, with hash, with compare, and the allocator is gonna be null, right? So that's okay, let's return it. So that's everything pretty much. Okay, so we also added the allocator for our hash map. That's pretty neat, right? And we have the full data structure now, so we can just copy this entire stuff into ds.h. But I also said that I need to implement this ds dynamic array delete, which kind of sucks, but yeah, I'll have to see. But yeah, now it can be just moved, so let's move it. So I'm gonna take all of these and let's go to ds hash table here. So I would actually just replace all of this stuff. I mean, I can say I had more stuff, like also hash table get ref, which is nice. But at the same time, I think that with the current implementation, if we let the user have like handle these memory addresses, you don't even need to get ref, because here you actually get a reference. Yeah, which I don't know, could be useful. I think it's better to do it like this, honestly. Yeah, because maybe it's a bit different. So for example, in the dynamic array here, when you append an item, you actually copy that item. So when you do get, you get a copy of it, you don't get the original item. And when you get ref, I mean, you just get a reference from inside of the data structure. So yeah, I mean, still it's still the same thing. So all right, so let's actually just try to implement the ds dynamic array delete, so removing an item from a dynamic array, and maybe even update, but for now let's just do delete first. So let's go into dynamic array, and let's have an extra function ds.h def ds dynamic array delete. Okay, so this one takes a dynamic array, unsigned index, and it is supposed, oh, it's a dynamic array and the index, right? And now let's go to our, I guess, where we define swap, and after swap we have our function. I guess it's fine just to copy paste the stuff that because we are gonna need the result, you know. Okay, let's check if the index is out of bounds first. Okay, and then I guess this part is gonna be kind of interesting. So I would basically like to shift, so I guess if we draw the thing, right, so let's well, it's too big, so let's imagine we have, oh shit, have a pencil. Let's imagine that this is our dynamic array. So the idea with the dynamic array is that you append to the end, and you don't really want to remove stuff from it. That would be like the main thing. So in our case, maybe if we wanted to remove stuff from the buckets, maybe a linked list would have been better, but that's too slow in my opinion when you want to append stuff to it. So let's just use a dynamic array, and let's split this into cells. So let's imagine that each cell is also filled, like that's another thing for a dynamic array. You fill the dynamic array and then you grow it to fill more stuff, like that's the idea. And if I want to delete this cell, for example, I have to take this value and put it here, and then this value and shift it. So that's the idea basically, right? So one way to do that, like the easiest way, is to use swap, right? We swap these two together, then we swap these two, and at the end we just say, okay, the count is smaller by 1. So that's gonna work, but I feel like that's gonna be too slow because we allocate too much stuff. We are gonna run malloc too many times. So another way, since we also know that the entire dynamic array is gonna be a huge chunk, is that we can mem copy this stuff, like from this pointer to this pointer, right? Like basically we shift the entire thing all at once, and yeah, I think that's gonna work much better. So I guess we just need to find those two pointers then, and we are just gonna run a mem copy on it once. So let's remove all of that. So we need the pointer from here and the pointer from here, and I guess mem copy, oh, I forgot how mem copy works. Huh. Well, let's check here because I'm pretty sure here is gonna work. Mem copy. So it says that it copies n bytes of source to destination. So destination is first, source is second, and then the number of bytes. Okay, that's pretty easy to imagine. So the number of bytes is gonna be item size. Okay, let's calculate unsigned int. What would be the number of bytes, right? Let's call it n. It's gonna be da count. Oh, I see. I mean, I don't have compile flags.txt. Implementation for dynamic arrays. So let's go back to delete. Okay, so how many items do we have? Well, we know the count, and in this example the count is 1 2 3 4 5 6, right? We have 6 items, and we delete from index 0 1 2 3. So you know, it's gonna be probably 6 minus 3 plus 1 items, and in this case it's gonna be minus index plus 1. And yeah, we made sure that the index is not higher than count. Okay, so like if index is 0, I meant here it's minus 1, right? It's gonna be minus 1. So yeah, like for example, if index is 0, you want to move everything, and if index is count minus 1, you don't want to move anything, right? So here we are gonna do n times that, right? And the place where we start the copy is gonna be I guess this is destination, is gonna be items plus index. But that's gonna be a bit of an issue. It's gonna be easier to do, yeah, this is gonna be easier. So I mean, you know, it isn't really that more difficult, but since this thing is void pointer, right, its size is gonna be 4 or 8, depends on your machine. And if we add 1 to it, we just add 4 bytes. But what if our item size is 24, or right, we want to multiply it with the item size? So I cannot really just do here plus index. I have to do plus index times item size, but you also have to cast this one to a char pointer, because otherwise you add, like if you add something to a pointer, you always add a size of its type multiplied with what you add. So if you, let's say, add 8 to a pointer and that pointer is void pointer, you're gonna add this amount. But if that pointer is a char pointer, you only add this amount, and these two are different, right? So you have to be careful with what type this pointer is. And I'd say it's gonna be easier to just use this thing because it does all the math for us. So for example, destination is gonna be this, and source, we just want the next index, right? src. Okay, and I guess if n is greater than 0, that's when we are gonna do all of this stuff. Because if n is 0, then we don't really care about moving stuff. Okay, so then here we are gonna just say dest and source. Right, we just go like mem copy destination, source, and size. All right, so here we just mem copy, and the next important thing is the count should be decreased with 1. It should be indeed decreased by 1. Okay, this is the only way an error can happen, so that's pretty neat. I mean, I still have this hash table which I have to HashMap. Okay, so now if we delete that and have the delete here, we should be able to delete age from the hash table, right? It doesn't complain, so something happened. Let's try to delete name, and then let's try to get name. So now we should get an error. Name is John, and then fail to find item in the hash map because it's no longer in the hash map, right? Okay, let's keep age, and let's have a method for printing a hash table. That's gonna be pretty neat. Maybe like dump. I guess. Huh. It could make sense. Yeah, actually, let's try to have it. ds HashMap pointer map. I was just thinking, okay, that means we need the dump for arrays as well. But yeah, the issue with printing is that we don't know how to print keys and values. So I have to do it like here. So let's do for, I mean, this is, you know, a bit scuffed. I is less than map dot capacity I plus plus, then if map dot buckets I dot count is equal to 0, then we just continue. Otherwise we can do stuff on the buckets. G is equal to 0, j dot count, right, j plus plus, and I was thinking I can even make this one into a function. My map print. Right, like this should work. Okay, then we have the ds HashMap kv. I can make it 0. Let's try to get into kv index j, but this is not right. I have to use ds dynamic array get. And here I need to use buckets j, like that. So now we have the k and the v, the key and the value. All right, and at least we know that the keys are gonna be strings. So that's one thing about our hash map. Like, we kind of know how to print the keys at least. So let's do printf %s, maybe \n char pointer kv dot key. At least we know that. Right. So maybe let's print fi just to see it. Okay, so it is happening. I'm curious, is it really all of them are 0 or something? Ah, some of them are 1, perfect. So that makes sense. Oh. Buckets I. Okay, so we get back name and age. Now the only issue is that data, or like value, is not always a string. Like, you can see that name is a string, but age is a number, right? So that's why I think it's a bit hard to do that. And I guess is before delete, right? And then keys after delete. Let's see that. So the keys before delete are name and age, and afterwards just name. And yeah, that's that kind of fixes our delete issue. That's pretty cool. Okay, but yeah, now as I said about this stuff, right? If I do kv.value is equal to I don't know, another name, Sam. If I do this one again, the name is still John. That's nice. So we didn't I mean, it's not here we didn't change the value inside of the pointer, we just changed the pointer itself. So if we do value of 0 is equal to I just have to do char pointer, right? And then like that. This should change it because we changed the shit. Oh well, that's not what I expected, to be honest. Right, like it's a bit weird because it's allocated here, so why cannot I change it? That's sad. But I mean, it is what it is. I thought I was gonna find something funny, but yeah, somehow because it's not allocated on the heap, I cannot change it. So I can do something like char pointer x is equal to malloc like 5, and then mem. Well, I guess this sucks, but am I stupid, or like how do you actually do this stuff in C? Because this doesn't feel right. And that's why I implemented how do you call it, ds.h, because I have the string builder in it, which saves you from this kind of stuff. Okay, whatever. But I must have like a brain leakage or something that I I had to do something like this. I'm pretty sure this is the correct way to do it, but yeah, whatever. So now that we actually allocated the memory, now his name is Zon, which is not John. See, like you can change it, but yeah, because this is C, you cannot really, like, you have to allocate the memory. You cannot do it like this, which I mean it's fine. Probably age is gonna work though, but yeah, I don't really care. So the delete now works fine. Yeah, I would still like to move this thing into ds.h itself and replace the old hash table, which I don't like for some reason. So let's do HashMap to store and retrieve items. The HashMap uses a separate chaining. Uses separate chaining. Am I stupid? Like, uses buckets to handle collisions. You can define the hash and compare functions to use when inserting and retrieving items. Yeah, I guess makes sense, right? So this would be the entire HashMap data structure. Pretty decent, I would say. So then is this HM implementation instead of HT implementation, HashMap, and let's search for HT. Okay, so yeah, if we do HashMap, we need the dynamic arrays. That's pretty obvious. So let's do HM. We can remove the defines and let's just copy this stuff into ds.h. Yeah, hash table count might be useful, but we'll see. So that's kind of how I... Oh, the allocator. Yeah, you can see that the allocator, it's really... Like, it was really fun to implement an allocator in C. That's something that I would really recommend. But yeah, that's my approach of adding stuff into ds.h, to be honest. So here we have HashMap, and I guess that now it should still work. Okay, but hash table, the sucky one, needs to go. I mean, we can still take a look at how I was thinking back then. So same thing, insert works the same. And yeah, the issue why I don't like this one is even if you have the size of available, you can say what size you want the key or the value to be. If it's a char pointer, you cannot really copy it in there, right? You cannot copy it like you can copy an integer. So that's why I didn't like this one. And yeah, to be fair, I mean, yeah, I mean, it is what it is. We can just remove it. Make sure it still work. And yeah, HashMap still works. That's perfect. Oops. So yeah, that's usually my approach to ds.h stuff. Just try to implement an example, and once it's almost finished, I just add it into the ds implementation. Yeah, I just need to add documentation now, but that's just something I will probably do. So yeah, but yeah, hopefully this was also useful. I mean, obviously the first part where I just implemented the data structure itself was more useful, but yeah, I really want to get back into doing more stuff with this library because it's pretty useful. Like, I use it in almost all my C projects. It's like 2500 lines of code, which, I mean, it's pretty nice. Obviously I still have to go through it and make sure that everything still works, because you know, making a lot of changes, and yeah, yeah, no, thank you for watching this part, and I'll try to see, maybe we can find like I don't know, JSON parser or something like that, where we can use the hash map. Because yeah, I had an older project, like probably the project that everyone started to follow me for, the one with the compiler, where I said that you know, I could use a hash map, but after trying to play around with it, I disliked it, and I continued to use a dynamic array instead of a hash map in that project. So yeah, maybe it's something to do with C or something. But let's try to build like a JSON, like a small JSON parser, and we'll use the hash map there. Let's try to see how the C hash maps like work, like how well will it work, probably, because yeah, it's gonna be interesting, like how are we gonna, well, that's gonna be No, I don't want to say that's gonna be easy, but yeah, that's probably gonna be easy. Like we'll have like how can we differentiate between different types of numbers and all of that, but that's gonna be the interesting part of what we need to figure out, right? Like somehow like yeah, I'd say that the goal for that project is gonna be writing a print function that not only prints the keys but also prints the values. So it's gonna be, for example, here I guess my mistake was I should have done something like another structure here where I have the name and type, right? String or something like this. So that's how you should actually do this kind of, each value has its own type. But yeah, I'd say that the goal for that is gonna be managing to print a JSON file after we read it in C. So yeah, I guess we'll see each other next time.